Hello, how's it going, everyone? This is John Jelinek, and I'm really excited about Clojure Mid-Cities tonight. We've got an excellent speaker, and then we'll have a demo following that. So I want to just do a quick introduction. So tonight's topic for August 3rd, 2020 is Intro to Biff. And so I'm definitely looking forward to that. So if you're new to the group, the meetup exists to help people explore the functional programming paradigm with Clojure so they can build simpler systems. And so functional topics, Clojure programming, things that are accessible to newbies, like those are the type of topics that we'll be covering in this group. For the agenda for tonight, kind of as we've done for the last few meetups, we'll talk about a plan for 2020. We'll get into a presentation, and tonight we'll also do a demo as well. So for the plan for 2020, pretty much like everyone else, right now we're just rolling with the punches. So you will find us on the Clojurian Slack. So if you're not in there, go to go Google for Clojurians. And you'll find the Slack page where you can request an invite. We're in the Mid-Cities Meetup channel. And so for this meetup, though, if you are ready to ask a question, you can go ahead and put in your question into the YouTube comments, and we'll be able to answer those live with our speaker. And but I'll also be viewing the Clojurian Slack channel as well for other conversation and dialogue and whatnot. I want to give a shout out to Daniel Craig. He helped us secure our speaker for this month, and so I'm super appreciative to him and his efforts because that's why you're getting to enjoy this awesome presentation tonight. Also, I wanted to bring your attention back to the meetup discount for Grokking Simplicity. So it's a book written by Eric Normand. He was a speaker of ours earlier on in the year. And so you can get 40% off on that book if you put in the code GRKSMPL2020. But furthermore, I have some discount codes that give you 100% off of the book. And so if you message me, just private message me in Slack, then I can give you one of those codes while supplies last. All right, so now let's talk about our speaker. So tonight we've got Jacob O'Brien. Jacob O'Brien started using Clojure for side projects while he was at BYU. He graduated at the end of 2017, worked for a year at Lucid Software, then quit to become a full-time startup founder. And you know, sometimes he calls himself a bum, but you know, it really depends on who you ask. He's been running Biff in production at findka.com, so FINDKA.com. So that's his startup idea number 3 since quitting Lucid Software. And so he's been running it for almost 3 months now after migrating from Firebase. And he likes long walks on the beach, and his favorite color is black. So if you don't know about Biff, Biff is designed to make web development with Clojure fast and easy, especially for early stage startups and hobby projects. So tonight we'll discuss the what, why, and how of Biff, and we'll go over how you can try it out on your next side project. We'll also talk about the long-term vision of Biff. And so with that, I want to introduce our speaker into the stream. So, hey, Jacob.
Hey, how's it going?
It's good. All right, so I'm going to share your screen, and we can get going.
Okay, perfect. Well, I'm excited to be here. Glad everyone else is here, even though I can't see you. But anyway, let's get into it. So as John mentioned, Biff is a full-stack web framework for Clojure that I've made somewhat recently. Let's see. And so this is what we'll all be covering in this presentation. We'll go a little bit more into depth of what is Biff, like what does it include. You know, you already have kind of the overall idea of what it is, but we'll cover what it does for you, and then I'll give a little bit background why I did it and a demo. I'll demonstrate running the getting started section from the Biff documentation so you can understand like what exactly would it look like if you were to try it out. And then just very briefly at the end, I have some thoughts about what I hope that Biff could become. So let's move on. Let's do the background first. So this is a little timeline of what I have been doing with Clojure. So as I mentioned, this in 2016 is when I started using Clojure, just a little bit on the side. And by January 2019 is when I started doing it full time on my own startups. And so over the course of this, was doing several different projects, as mentioned. First couple of startups did not turn out super great, but current one seems to be doing a lot better. But the nice thing is I had a lot of opportunities to experiment with different web technologies and libraries and things. And there are certainly pros and cons to a lot of them. And by early this year, I had sort of kind of settled on Firebase. I started using just a few features from Firebase about a year ago, mainly just hosting and authentication, which were very nice, highly recommended. But I hadn't used some of their other core features like the database and back-end cloud functions for Firebase. But in early of this year, I decided to try those out, and I switched my code over from Datomic and AWS to Firebase completely. And it was actually a lot better than I thought it would be. I was pretty happy with it. But after a few months, I found I was still kind of running into a few limitations. And at the same time, I also had kind of this aha moment when I realized that a few of the core features of Firebase, I realized how I could implement them from scratch using components from the Clojure ecosystem. And so at that point, I had the gears turning in my head and couldn't stop thinking about it. So I started working on Biff. And then by early of May, I had completely migrated my code over from Firebase to Biff, and I've been running it ever since, and it's been very nice. So that's how we got here. So to jump into a little bit more of what does Biff contain. So this is just a little overview of the source code for Biff. So there's actually not a lot of code in Biff. Total, it's about 1,300 lines. And most of it is backend. So Biff, as opposed to, say, Fulcro, is not very front-end heavy. Fulcro has a lot of front-end code, whereas Biff is mainly like backend things, a little bit of front-end just for syncing data between the backend and front-end, and then a little bit of just DevOps, sysadmin type of code to help you, not have to spend much time deploying your application either. So I'll go on to the next slide. So far, do we have any questions so far?
All right. So I see a question here in Slack. So I'll ask that one. It's from Proctor. He says, question on config in Clojure. I've heard Clojure folks talk about the move to make as much things toward the data side. Does anyone have good examples of the push to treat as much as data? So I think that this is maybe not specific to the presentation, but it sounds like you're kind of still talking a little bit about that in even that you're mentioning it being a back-end library with more focus rather than Fulcro with its front-end stuff. So I don't know if there's anything you want to talk to about that.
Yeah, I think actually in about 3 or 4 slides, actually, we have some really good examples of that. So maybe give me a few minutes and I'll get to that.
Okay.
But yeah, it's a great question. And so it's, in particular, it's the way I've re-implemented some of Firebase's features are the API for using it is a little bit more data oriented than it is when you're actually using Firebase directly. So I'll be sure to point that out once we get there. All right. Okay. So let's move on. So I've, in trying to explain a bit more what exactly is contained in Biff, I've kind of separated it into these 3 categories. So the first thing that Biff does for you is it curates libraries. So you are familiar with Clojure, you might have heard that there's a community preference for using libraries over frameworks, and I won't get into that too much because lots of stuff has been said and it's been written much more eloquently than I could say. Anyway, in general, I think that is very good because libraries are composable and easy to put together and take apart. But the downside is that there can be a significant effort involved with putting those libraries together, especially if you are new to Clojure. So what Biff does is, we've picked a lot of those libraries and put them all together for you on the back end so that you don't have to do that unless you want to. Yeah, so this is example, a lot of the common things that, just about any web app will need. These are some of the libraries, not all of them, but sort of a representative sample of the things that we've put together for you. And so in scope, this is kind of similar actually to what Luminous does, if you're familiar with Luminous. I actually have not used Luminous myself. I wish I had, because I think it would have helped me learn how to do Clojure web dev a lot faster. But my understanding is that one key difference between what Biff is doing here with curating libraries and Luminous is that Luminous is more of a template. So Luminous curates a bunch of libraries, but its purpose is to teach you how to put them together. So you have this template that Luminous gives you, and maybe you copy it into your project and then modify the template. Whereas Biff, all the libraries are wrapped into another package. And so by default, all you have to put into your own code base are these function calls. That's not quite true. There's a little bit more you actually have to do, but more or less, all this stuff is kind of swept under the rug and hidden behind these function calls. Now, the downside of that is that sometimes you need to get at individual libraries and switch things out, and that's kind of why we have a community preference for libraries in the first place, because a lot of times frameworks will get you 80% of the way there, and then you have that little bit at the end, and it turns out that in order to make the framework do what you want, it takes a lot of extra effort, and it would have been easier if you had just sort of composed all the libraries at the beginning on your own. So with Biff, I have a focus on keeping it decomposable. So ideally, you should be able to start out with just that one function call to start Biff. Excuse me. But if you do get to that point where you need a little bit more freedom to configure things, you should be able to take Biff apart without it being hard. So this is an example of, so last slide here we have this start Biff function, which is kind of the main entry point to Biff. And this is the source code for that function. So it is expected that if you need, you should just copy this function into your code base, and then you can modify the individual things here. So for example, Sente is the library that we use to handle WebSockets. So if you wanted to change the way that Sente is initialized, you could copy the start Biff function into your code base, and then copy the start Sente function into your code base, and then you can change that function however you want. But then the rest of the functions you can still use and not have to worry about them, and basically you can keep going down layer by layer until you have exactly the level of abstraction that you want from Biff. Let's see, I think that's about it for that. So do we have any more questions?
I've not seen any yet, so you're good to keep going.
All right, perfect. So yeah, so that's the first kind of main thing, the curation of libraries, so that hopefully you can get started quickly with Clojure and not have to spend tons of time Googling before you can get Hello World up. So the next bit that I mentioned is system administration. I still can't quite bring myself to say DevOps instead, but I don't know, it's the same thing, I guess. Anyway, there's not a whole ton here, just a little bit. So the first bit that we have is this. It's just a simple bash file and install script for DigitalOcean. It's not like tightly coupled to DigitalOcean, but I haven't tested it on anything else. So if you wanted to run it on AWS or some other cloud provider, you might need to do a little bit of configuring. And eventually I'd like to replace this with Terraform, but for now this file is simple and works well enough. But anyway, so this file will do a certain number of setup things. It'll install Java, install Clojure. It will set up certificates. It will set up a firewall, set up Nginx, blah, 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 a few other things. And let's jump to the third point. So after you have this install script ran, the way you get your actual application onto the server is we're using a feature from tools.deps. So if you're not familiar with that, it's an alternative to lining in. It's one of the build systems for Clojure. So this is an example of a deps.edn file from that you would use with tools.deps, excuse me. And this is actually what it will look like on the server. So to deploy your application, you have this deps.edn file, you put it on your server, and you use a git dependency feature. So tools.deps lets you specify the URL for a git repository, and you specify the commit hash. And then when you run Clojure with that file, it will download the hash right from the Git repository and run it for you. And so that's what we use for deploying your app. So if you wanted to deploy on Biff, you set up your Git repository on GitHub or whatever, push your commit, and then you would SSH into the server, edit this file, update the hash, update the URL, and then restart Biff, and then it will pull your code from Git for you. It's very nice. Also, if you delete this hash line and just start Biff without specifying a hash, then on startup it will go look up the most recent hash and then add that to the file for you. And so that's usually what I do. My deploy process is basically SSH into Biff. Well, it's push the commit first, then SSH into the server with Biff, delete that hash, the SHA line, restart Biff, and then it'll be up and running in a few minutes. Okay. So yeah, let's see other things. So backend server contract. So as I mentioned, Biff is not tightly coupled to DigitalOcean, although it's what I'm using currently. But the backend Clojure code does expect a few things from the production environment that it is running on. So for example, it expects that you have a different web server that is taking requests from the outside world and passing them on to the Clojure process. So in this case, Nginx, but it doesn't technically have to be Nginx. So the backend Clojure code will be listening on port 8080. There's a few other things. It also expects that static files will be served from a certain directory. So when the backend Biff code starts up, it will take any static files that you've put in your project and write them to that directory on the server so that they can be served by Nginx or whatever other web server you have. As an aside, one nice thing about that is at the moment I don't have zero downtime deploys set up for Biff. So currently there's 30 to 60 seconds of downtime if you deploy. However, since static files are served directly by Nginx, any static files will not have downtime. So you can at least have half of your app working while you're doing deploys, and eventually we'll fix the zero downtime thing. And then we have, I won't get into this too much, but we have a simple setup for handling configuration and secrets, nothing too complicated. That is everything for system administration. Do we have any questions before I get into Firebase stuff?
Sure, yeah. So I did see a question. So Ivar asks, does it work with private repos on GitHub?
Yes, it does work with private repos, and I have a section about that in the documentation. Um, I'll I'll show you where the documentation is for Biff, by the way, a little bit later in the presentation. But there's just a little bit of extra setup you have to do. You have to add a deploy key from GitHub onto the server. But that's about it. So I'm using that for Findka. Actually, I have a private GitHub repo for that.
Great. Awesome. Yep, that's all the questions for now.
Okay, perfect. All right, so this is the sort of the third and final section of what Biff does for you. And this is the part that I'm really excited about, because this is kind of what got me into writing Biff in the first place. So Firebase. So this is a little diagram I made. So I'm going to use it to sort of try to explain why Firebase is cool in the first place and what it does for you, at least part of what it does for you, because now Firebase has a lot of features. Anyway, let's zoom in on this little section. So views, events, model. You may be familiar with, this kind of thing. So this is the front end of your app. And this is not specific to Firebase, but this is sort of a model that we get from React, right? The nice thing is the idea is you have a model where your front end state is stored, and then you define a pure function which takes the model as an input and then outputs the views. And then as you're using the app, if you click on a button or whatever, you can trigger an event which will change the model. But then the cool thing is it's reactive, which is where the name React comes from. So if the model gets changed by an event or whatever, then that pure function you defined for your views will run automatically and update the views. And you do not have to coordinate when that function runs. You just set it up at the beginning, and then you can just work with the data, just modify the data, and then the updates will happen automatically. So again, that's not specific to Firebase or Biff, but it is a very nice model that eliminates a lot of complexity. So now the problem with this model is that it's just on the front end. What we'd really like is if you could have this model be not just your front end state, but your entire database. So you could have, your database that has the entire state for your application, and then have a pure function which defines your views. So, and then, whenever a transaction or something modifies data in the database, this pure function that you've defined will automatically run and update any views on your clients. Now that's difficult because, for one thing, for scaling reasons, the database is very large and there are security implications. Even if you could load the entire backend database into each client, clients aren't allowed to see everything in the database, so you have to make sure they only have a slice of the database. And so it's difficult, but not undoable. And this is this is basically what some of the core features of Firebase give you. And so that's like when Firebase was first released, kind of the big thing is, they had this JSON document store, which allowed you to subscribe to certain parts of the backend database. And it's improved a lot since then, but that's still, kind of one of the main features, I'd say. And so the idea is when your client starts, it can send some information to the backend that says, here's the data from the backend that I'm interested in. And then whenever, the backend database changes, or if any of those slices of the database change, then just those bits will be sent to the client. And then once they're sent to the client, this pure function will run, and then your views will update. And then also, transactions, you can have the front end send transactions directly to the database. And so Firebase gives you this thing, and it gives you a feature called rules, which allows you to, define who has access to what, who is allowed to change what in the database, so that you're not just giving, complete open access to your database. However, it's almost like you do have access to the database, because you don't have to go through any like custom HTTP endpoints or anything. You can more or less have queries and submit them directly to the database, and then have transactions and submit them directly to the database, and still have this nice functional reactive programming model. Okay, so again, that's Firebase in general. And so what Biff does is that it also allows you to have this kind of thing, but it's been re-implemented. So on the right here, this is some examples of what the code actually looks like if you're using these features in Biff. So first of all, like this little arrow, if you're sending information to the backend to subscribe to some data, up here, you format it like this. So this is a Sente event, and you say, table. So what kind of document am I wanting to subscribe to? A user document. And then here are some attributes on that document. And so you say so user ID something. So you're saying, I want the document with this given user ID. And this subscription looks a little bit like Datalog, but it's not. It's a lot less powerful than Datalog. But it does get translated to a crux query. If you're familiar with crux, it's a immutable database written in Clojure, and it supports Clojure data. It's very nice. You should look into that. Anyway, so you can subscribe to these things that are not as powerful as Datalog, but they do give you basically the same level of power that Firebase subscribable queries give you. And it turns out, even though they're not super powerful queries, you can actually go quite far with them, and there's more about that in the Biff documentation if you're interested. Anyway, so that's what this arrow looks like. And then as far as this arrow, you do not have to think about that at all, because Biff just handles it for you. The next bit with transactions. So if you want to change stuff in the Biff database, you can submit a different sent event. And so this is also sent from the front end. Both of these two things, you do it from the front end. And this is what it looks like. So the Biff transaction format is very similar, again, to the Firebase transaction format. And so you specify two things. So you have a map of changes you want to make, and each key is specifying what document you want to change. So the first element here is the type of document, users, like we have up here. Then this is the ID, same as right here. And then this is the replacement document that we want. So by default, if you give it a document, it'll just completely override or overwrite whatever document is there. But if you specify merge, then it will just merge the new data you're giving it, so it won't clobber your old data. So here, this is a transaction. We are changing the name of a particular user to Alice. All right, so hopefully that makes sense. And so then here, the key part, the rule that lets this be possible from the front end is defined here. So here is, oh, actually, I just remembered that question we had a few minutes ago. Let me back up 2 minutes. So the question from before was, maybe what are some examples of doing things more data-oriented? And actually, both of these are perfect examples. In Firebase, by default, the API is more imperative. So if you wanted to subscribe to a piece of data, you have to, I don't remember what the variable names, but it's something like firebase.firestore.subscribe, and you call this function and give it the data, and then it mutates some data and subscribes for you. And then if you want to unsubscribe, you have to call, some other function. What I've done here, so the thing though, and also along the way with each one of those function calls, you have to give it, there's one function call, you give it the name of a table, and then it will, well, they call it a collection, but you give it the name of a collection, and then Firebase gives you back a reference to an object that represents that collection. And then you call the next function and you give it these attributes that you want to match on. And so with an imperative model, that kind of fits if you are tying your subscriptions into the life cycle of your application. So kind of the canonical example is a chat application. So you have a chat room and you click join, you're in the chat room, maybe you set up some code so that, okay, when the user clicks this join button, we are going to fire this imperative code that will subscribe them to that slice of data. So what I have done with Biff is I have turned this more into a data-driven API. So instead of calling functions, all you do is you craft this data structure. So this is just plain data, but it has all of the information that normally you would have passed into function calls with Firebase. And so like I mentioned, table here, the information here is all data. And the thing that makes that really nice is you can separate your subscriptions from the life cycle of your application. That was one of the pain points I ran into with Firebase, is that you're sort of if you complex the life cycle of your application with the code, it gets a little bit more complex. With Biff, we have it set up so instead of doing it imperatively, you can define another pure function that defines what subscriptions you should have given the current state of your model. So again, it's sort of the same situation as like this arrow. You define a pure function that says your views. It's the same way. You define a pure function that specifies what subscriptions you should have. And then as your data changes, it will change. So for example, if you click on a button to join a chat room, instead of firing the code to subscribe to that chat room immediately, it will change the data in your model that says, I am now in this chat room. And then when that model changes, it will automatically update your subscriptions and subscribe you to the stuff in that chat room. So now you've separated that logic from the life cycle of entering a chat room. All right, that was a little long-winded. Hopefully it makes sense. I have some more examples of that in the Biff documentation. And also, I actually have written a wrapper for Firestore. So you can actually have this kind of similar thing with Firestore too, if you want to use that. All right. All right, let me finish explaining what rules are, and then I'll pause and ask for questions again. Okay, so as mentioned, you don't want to let clients just make any kind of change to the database. So what we do is we set up a function that will authorize any kind of read or write. So I'll just take it by example. So say you're running this transaction. What Biff does is, so Biff will receive this transaction for you, and then it will look at each item in this hash map, and then take the document ID and look at those documents in the database, unless you're creating a new document and then it's not there. But it'll look it up and and here's the sequence. It'll look at this data structure. So this is a data structure that defines your authorization rules. And the first thing it'll do is it'll look at Spec. So Spec has two things that specify the shape of data that you can have. So what this means is that in the users table, the ID for this kind of document should be a UUID. And the document itself should follow this spec. And so up here we said this, a user, okay, oh yeah, I got it right here. So a user document is only allowed to have a name attribute. So that's the first thing we do. Biff will check if the shape is right. So if we added some other attribute like age, then immediately Biff would reject this transaction because it doesn't match the specs. All right. Now, if it does match the spec. So the next thing it'll do is it will look up an authorization function, which you define. So there are 5 different operations you can do. There's get, query, create, update, and delete. But they're aliases. So if you do read and write, that'll just get everything. So here we have a key, and it's a little bit scrunched up, but what we're saying is we've got a read and write key. So we're saying if anyone tries to read or write a user's document, then run their proposed change through this function. And if this function return, oh my goodness, I just realized the bottom half of this function is cut off. Oh, that's embarrassing. I'll have to just tell you what the last line of it is. Anyway, so this function will run. If it returns true, then the read or the write is authorized. If not, it's rejected. And so what this last line should have been is it just says equal UID ID. So session UID is it's the ID, the authenticated ID of the current user, and then this ID here, let's see. Oh, actually this is a mistake too. This should be crux.dbid. Anyway, this ID should be this UUID that you've passed in. And so it'll check to make sure if you're trying to change this person's name to Alice, it'll just say, is this UUID equal to your authenticated user ID? So is this actually you? And if so, it'll allow it. If not, it'll reject. And a similar thing with reading. It'll say you're only allowed to read a user document if it's actually you. Anyway, any questions before I go on to the next slide?
Yes, actually. Ivar asks, how robust is the disconnection handling for the subscriptions? So, for example, if I disconnect for a few minutes, what happens when I reconnect?
Mm-hmm. It is somewhat robust. I do have logic for resubscribing. So if there is a disconnection, and I'm trying to recall exactly what, because it's been a little bit since I've worked on this, but there is code. So if there is a disconnect, then it will basically just rerun all the subscriptions again and get your data. So it should be okay. However, I have noticed when I update my backend, sometimes the Sente closes the WebSocket, and right now Biff doesn't automatically reopen the WebSocket, and so in practice, when I've been updating Findka, I've had to hit refresh on it. So currently it's somewhat robust, but that can change and eventually will change, and so yeah.
Okay, great. There's another question from Ivar. Are the spec rules applied client-side, or do they always get run on the server?
They are always run on the server. Theoretically, they could be run client-side, maybe, if you wanted, like if say you wanted to have, let's say you had like some kind of input form and you wanted to make sure the user was entering valid information, you could theoretically define the specs in a Clojure file and then run them that way. Currently, we don't do that. Currently, it's just on backend.
Okay, great. And then here's a 2-part question from Daniel Craig. He says, can Biff coexist with reframe, or does Biff tread the same ground as reframe?
I'm glad you asked that, because I was actually thinking about that exact question in the past 1 or 2 days, which I hadn't really thought about before. So the answer is, I think so. I'm pretty sure that, yes, you absolutely could use reframe with Biff. I have not done so myself. I really haven't used reframe that much at all. Excuse me, to be honest. I looked at reframe a little bit about a year plus ago and decided for the simple things I was doing, I would rather just use plain reagent. And also I found from using Firebase, when you have this kind of setup, a lot of the state management is kind of handled for you, which is nice. So for example, I don't have this feature in Biff, but Firebase, like Firestore, will automatically handle optimistic updates for you, for example. So, you can submit a transaction and it'll send it to the backend, but immediately it'll also apply it to your client-side database. But then it'll find out, oh, does the backend fail? And if so, it'll roll the client one back. So anyway, I don't have that in Biff. I'd like to do that later. So pulling it in, some of those features are potentially handled. So you depending on the complexity of your application, you may not need to. However, yes, I'm pretty sure you absolutely could put reframe with Biff. The main thing is the front-end API for Biff is basically two things. It's two atoms. So you define an atom that will contain all of your subscriptions. And so the way, in the example, I have a particular way that I populate that atom with the subscriptions. But you could do that however you want. You could plug it into reframe and use materialized views. I don't remember what they call those in reframe, but you could do whatever those are called to define your subscriptions. And then the other thing I don't know, I'm going over that. The other part of the front end interface is another atom which contains the results of your subscriptions. So if you were to just define something with reframe that would watch that atom and then take the contents of it and put it into your reframe atom, then you could totally drive a UI with reframe.
Awesome.
Okay.
Thanks. That's all the questions for right now.
Okay, sweet.
All right.
All right, so let's get on to the next bit. So this brings up the question, why not just use Firebase? And so these are basically the core reasons why I switched from Firebase to Biff in the first place. Because as I mentioned, Firebase kind of had some limitations. There are sort of random application-specific things, so I won't get into them too much. But in general, the nice thing about Biff is that it's open source. And as you mentioned, not only is it open source, it also really does not have that much code, only 1,300 lines. So it wouldn't take, some of that is a little bit of a spaghetti mess, but it wouldn't be too hard to get into it. And so if there's anything you don't like in Biff, you can change it. And same thing for self-hosted, you have total control. Whereas Firebase, you're a little bit more stuck with the way they've done the framework. Big thing is Jvm Back End. I have a lot more time spent using the Jvm on the back end, which I think is common with Clojure people. Not necessarily, I know a lot of people also use Node. But anyway, if you prefer to use Jvm on the back end, then this can be a significant advantage. And then also to elaborate on that, one, you have performance characteristics of the JVM, especially because it's a long-running process, as opposed to Firebase. You have these ephemeral node functions which spin up and down, which, at least in lower scales, I was finding there was somewhat significant cold start issues. I had a particular flow in my app where, I send users an email every now and then, and it has a link to log in. And Firebase has that feature, so you can, log in through a link. However, I was doing things a little bit differently that I couldn't just use their solution out of the box. And so the result is if a user clicked on this link, they would go to a cloud function, which would do some processing, and then it would contact Firebase's normal authentication backend and get a link and blah, blah, blah. And the whole thing sometimes would take 10 seconds just to run, which was unfortunate. Maybe, if I had lots of people actually using the app all the time, maybe cold start wouldn't be an issue, I don't know. But right now it is an issue for me. And Biff and JVM is just very fast. It's always running. And then also the library ecosystem is nice. You have access to all the Clojure libraries. And then it's a little bit more Clojure. As I mentioned, all the components of Biff have been built from the ground up for Clojure, so some things are a little bit more data-driven. A good example, I think probably the best example, is the rules. With Firebase, as far as I'm aware, the authorization rules just run on the cloud. I might be wrong on that, so sorry if I'm wrong. But in my experience, they were error-prone and a little bit hard to debug because you'd push some authorization rules and then try running some transaction, and then you'd get a null pointer exception because they use a sort of a JavaScript domain-specific language for doing these rules. And I found that sometimes I'd have these null pointer exceptions, and then I didn't know what document it actually was that triggered it, and I couldn't figure out like what is going on here. Whereas with Biff, you have it's all done with like Spec, as I mentioned, very Clojure kind of thing. So that's very expressive, and it's just regular Clojure backend functions, and so you have some of the nice REPL-driven development features of doing that. On the other hand, there are some real benefits to using Firebase. So especially like if you are familiar with Node development and you like to use Node on the back end, or if you're just, if you're doing something simple like a weekend project and you don't think, running into limitations is really going to be that big of an issue, Firebase very well be good enough. And if you want to go that route, I have another repository. It's called Mystery Cows. It's a implementation of the board game Clue. So it is a non-trivial application that has been written with Firebase and Clojure script. And actually, it's quite nice, in my opinion. So if you're interested in using Firebase, I'd certainly recommend checking it out and check that repository out. All right. So that is sort of the end of what is in Biff. I have a little demo here, and I'm going to get started on that now. There is one section of the demo where I will have to wait for it to compile some code. So I'm going to ask if there are any questions during that part, because then we can multitask. So by the way, this is the documentation for Biff, findka.com/Biff. Excuse me. Okay, and I'm going to just demonstrate briefly. So if you want to check out Biff, you can go here and there's a little bit of introductory information. But you can just go to this Getting Started section and just run through these steps, and this will have a application running on your local machine right away. There's another section you can go to for production, which will show you the steps for getting it running on Digitalocean. I won't go through that right now because you'd probably get bored, but let's look at this and let's see if the font size on this, let me increase it a little bit. If it's too small, just let me know, John, and I'll fix that. Okay.
It's looking good so far.
Looking good? Okay, perfect. Okay, so you'll have to have some things installed, and let's see. I did this before. Okay, so if you're here, you can, actually no, I'll do git clone. Oops. Why is select not working? I promise I know how to use a computer. Okay, I'm just going to type it. I normally am able to type, or I mean copy and paste, but I guess not today, unfortunately. So you'll clone the repository. Now, if you're actually wanting to deploy your own application, you would want to make your own repository, since we use Git for, like if you're updating your application, and obviously you can't put your application on the same repo. But for just trying it out, cloning is fine. Oops. Oh, I'm already in here. Okay, so example. This is a little application which I have written with Biff. It's in the Biff repository, and it is tic-tac-toe. So once you clone the repository, you can run, oh yeah, so tasks. So I have a little bash file which just has a little few build tasks. And when you first clone, you want to run setup, which basically installs some npm dependencies and maybe something else I don't remember. Should be over shortly. Ah yes, and it's auto-fetching the latest version of Biff. Alright, so we've run that. So now, task dev. This is a command which will start up two things. It starts up a Clojure REPL for the Biff backend, and it also starts a shadow Clojure.js JVM, which you can use to compile the Clojure script code. It's a little bit slow because those are two separate JVMs, and actually I fixed it in the findco repository, so instead of doing two separate things, we just start the Clojure backend JVM, and then we start shadow Clojure from inside of that, so it's faster. I have not made that change in Biff yet, so this will take a little bit. But in the meantime, do we have any questions?
Yes. Okay, so here's a question. So have you considered writing mystery cows to use Biff as a point of comparison?
I haven't really considered it. That could be very interesting to do. For me, it's mainly a time constraint since I'm working on my startup. But if someone else wanted to do that, I think that would be an extremely interesting way to learn how to use Biff and stuff.
Yeah, sounds like a exercise for the audience.
Yeah.
Yeah.
Yeah. I haven't mentioned this in the presentation. There are potentially some more really cool features coming up for Biff. If you've seen me write about Biff before, you probably know that I've written a lot about Materialize, which is a company that it basically lets you subscribe to arbitrary SQL queries, which is extremely exciting. Because as I mentioned right now, the queries that you can subscribe to with both Firebase and Biff are a little bit restricted. But theoretically, you could do an integration, and actually I have written an integration for Materialize and Biff. It's extremely slow because you have to use Kafka, and so I haven't released it yet. But you can set it up so that you can basically subscribe to arbitrary SQL expressions, which gives you a lot more power, which is super interesting, but yeah, not here yet.
That sounds really cool.
Any other questions?
Nope, no new questions yet.
Okay, perfect. All right, so this, and actually looks like we have perfect timing. So let me scroll up here, okay, maybe it's not worth it. Let's see, if you're starting this, you'll notice, okay, I don't know where it is, but anyway, there's some part where it says, Biff starting, and then here it'll say system started. So now you know the Biff backend is running. And so your app will be running on port 8080. And now here we also see Shadow Clojure is running on 7890. So I'm going to go over to Firefox, and so you'll want to go to Shadow Clojure first. And then you can go to builds and hit this checkbox, and it'll start going. And again, that'll take a while because I'm on an old laptop and streaming probably doesn't help. But in the meantime, we can go to 8080, which now has our application. And this is what it will look like. So authentication in Biff right now is just email link, so there's no user password, there's no sign in with Google or anything. You type in an email address and it'll send you an email, you click on the link, you're logged in. The example app does not actually send you an email, it just prints it out to the console and then you click on the link. So you have to provide your own, you have to provide your own email function, which is pretty easy, like with Mailgun, for example. Anyway, so hello@example.com, hit this button, and boom. So this is a data structure which normally would be passed to a function which you define, and so that function will take this data structure and then format it into an email and send it to you. But let's see, I have to wait for the Clojure code. It's taken forever, probably because this is the first time we ran it. And so it's compiling everything, but future compiles are faster. Anyway, once this finishes, we can click on this link and we'll log in. And so let's just give that a second, and hopefully it doesn't take forever. I'd tell you a joke, but I'm afraid that... Oh, did it just finish? Oh, never mind. I'd tell you a joke, but I'm afraid that, yes, it would finish before I told you the joke, and so yeah, sorry. So, open the link. Here, what? Okay, let me just try that again. Maybe it expired or something. Obviously, of course, that's what's going to happen when you're, demoing it live. Didn't happen the 5 times I tried it before. Okay, here we are. Let me close this. Close this. Okay, so we have logged in. We are hello@example.com. And let's set our name. And as I mentioned before, I don't have optimistic updates yet. So you'll notice when I type in something here, there's a short flash. And that is the amount of time between submitting the transaction and then getting the new data from the backend. In practice on FindCo, I've written, it hasn't really come up as an issue, but FYI, that's one of the issues on the Biff GitHub repository. So if you're interested in getting into the code, that's something you could work on. So you can click on here, and I'm going to open a private window because I use session cookies for authentication. So if I opened another tab in the same browser, it'd just be the same account. So let's do hello to example.com. And go back to here and copy the link. Bum, bum, bum. All right. Now here, by the way, this is a little printout of the entire client side. Well, it's either in the entire state or almost the entire state. It is the result of all your subscriptions to Biff. So for example, the users table, we have a user document, and here's your document, there's your email, there's your user ID. So for example, if you wanted to submit a transaction to change your display name, you could get your user ID from here and then do a transaction, blah, blah, blah. Anyway, so here we are. It's Bob and A, B, C, D. And here we are. Woohoo. And you can have more people actually sign into this game ID, and they'll just be viewers. And we can click here and do stuff. And if you try to click in a row, it won't let you because that's not allowed. And voila, it's tic-tac-toe, which I'm sure you've never seen before. Okay, so that is the demo application. Do we have any, I'll clean this up. Do we have any questions before I go on to the final slide?
I don't see any new ones right now.
Okay, perfect. All right, I'll get this up. And once this is done, you can all be through with me. So Biff, as I mentioned, I've been using it in production for 3 months, and if I haven't made it clear, I should make it clear now that I love Biff. I think Biff is the bee's knees. But it obviously has a long ways to go. If you go on the GitHub repository, for example, I've got a bunch of issues, and some of those things are things that I just need to get around to doing. I haven't been doing too much cleanup on Biff because I'm at a point with my startup where I think we're almost, we've almost fixed retention. We have people signing up, but they never stay. They always leave. But if we just fix that, then we'll be in a much more stable state, and then I'll be ready to take more time to go back and clean things up. Anyway, so there's a long ways to go. However, I do think there is something really special going on here with Biff, and I think it could potentially make web development in Clojure a lot easier for a lot of people. I would love it if we got to the point where someone who is new to Clojure or somewhat new to Clojure could just get up and running and have a working web app and be able to start actually implementing their app idea soon, instead of having to just learn sort of the web development basics from the ground up. But then, of course, as time goes on, still learn how everything is working under the hood. I do think that the example of Rails is quite inspiring, because Ruby was not always a super popular language, and Ruby on Rails, made a big difference in that. Now, Clojure, I think, is a lot farther along than Ruby was before Rails came along. I mean, obviously there are tons of companies and large companies that are already getting lots and lots of value out of Clojure. However, I think there's still lots of improvement that could be made. So in general, I'd love it if Biff could become a community effort. The biggest thing we need right now is honestly just people to try it out. And just let me know how it goes. And the documentation especially is a high priority for me. I've put a lot of work into it, so I hope you like it. But just updates to the documentation and clean up with Biff and adding more features and things. I would like to make it a very smooth experience for people getting into web development with Clojure. So anyway, thanks. Here's my little self-promotion bit. So yeah, here's the link to the Biff documentation and my startup. You should all sign up. And then my personal website has some links on it. Thanks everyone for coming.
Awesome. Thanks, Jacob. So I'm really excited to try out Biff. So hopefully in the next couple weekends or so, I hope to try it out. I did see there was another question that came in. So J.R. Smith says he's never used Sente. So this may be a dumb question, but is there any way to use Biff as a backend to support a vanilla React app? And then also, is there any GraphQL support?
Okay, so first bit is theoretically, yes. It would take some work, which I haven't done, but yeah, to use it with a vanilla app, like probably the easiest way to do it is you would have, if you just compiled the front end bit, because there's, like the Biff Clojure script is basically just like, excuse me, keep burping. It's like 100 lines of Clojure script and the Sente front end, of course. But if you added just a little bit of Clojure script, you could export some functions so that you can, use the Biff front end API from JavaScript directly, and then compile it into a file and then just include that in your app. I don't know how heavy the front end for Sente is, so and I have not looked into the implementation detail. I did a long time ago, like a year and a half ago. But if you're wanting to get a little bit more lean, I'm guessing maybe you could sort of implement some of those bits from Sente, and just have that. But yeah, so again, in general, it should work. It will require some work, which I haven't done, but yeah, it should be possible. Someone on Hacker News actually asked kind of the same thing. And for the other question, GraphQL support, no. For one thing is because I honestly have really not used GraphQL much at all myself. So the only exposure I've had to it is once when I was consuming the GitHub API, and when I was using Fulcro, which isn't really GraphQL, but it's Pathum or EQL, which is apparently kind of like GraphQL. So it doesn't, and to tell you the truth, I don't have a complete understanding of, since I haven't really used it in earnest myself, I couldn't give you a very good comparison of would you want to use GraphQL in Biff, or if you wanted to, how would you integrate it? I don't know, but another opportunity for someone who has actually used GraphQL to maybe help out there.
Sure. Awesome. All right. Well, thanks a lot for speaking today, Jacob.
Yeah, thanks for having me.
All right. Okay, so I'm going to move us back over. So we're going to change our screen over to Mike Nygaard, who has a demo for us. So Mike, hey, how's it going?
Hey, great.
Good.
I really liked Jacob's focus on the adoption experience and the getting started experience. It's always been a little bit rocky for Clojure.
Sure. Yeah, I'm super excited about that, and I can't wait to see how it matures. All right, so I'm going to share your screen now and pass it on over to you.
Yeah, so as it happens, we have an accidental theme for tonight's meetup, which is the onboarding or the getting started experience. When you try to contribute to a project, sometimes the setup alone, getting to the point where you can run tests and make a meaningful contribution, that can be enough of a challenge that people actually just stop there. I've done it. I've had projects that I wanted to contribute to, but I couldn't even get my dev environment to accept whatever the setup was. And then I'm trying to make a one-time contribution, and I've polluted my environment with new languages, new versions of libraries, yet another GCC tool chain. So I was pretty excited when I saw this announcement from GitHub about code spaces. The idea of code spaces is that they're going to run a container for you that contains the code of your repo. So it's going to clone your repo into the container, and it's going to do whatever other kind of setup you decide needs to be done for that container. So I'm going to give you a little demo. Now, advance warning, it is a beta feature from GitHub. So some things are a little flaky, like the user experience is not perfected yet. Particularly one of the tricky bits is debugging when things go wrong. So I'm in Chrome right now, and I will tell you, use Chrome. They recommend use Chromium or Edge or a Chromium-based browser. They mean it. It does not work in Firefox. So when you get into the beta and you go to the code spaces panel, this is what you're looking at. Oh, interesting. I have to put my mouse in a different position to get the cursor to look right on the stream. So initially, you'll have no code spaces. And the idea is that you want to create a code space. And here I have to choose the repository which will be cloned into the code space. Now, in this case, I'm going to choose one of mine. It's a repository I created just recently for the purpose of an easy, fast start to a Clojure project with my favorite tech stack, which happens to be one largely created by Cognitect, my former employers. I'm going to create the code space, and what's happening now in the background, GitHub is running this container on their infrastructure. So they put some limits on it. You can only have 2 code spaces in your account during the beta. So they've started a container instance from an image that I specified. And while this is firing up, I'll show you how that works. In the repo, you put a folder called .dev container. Now, if you've done anything with Azure code spaces or Visual Studio remote container development, this will look pretty familiar. It's the same convention. So .dev container, and inside there, devcontainer.json provides instructions about what the container should be. Now, in this case, I'm saying that I'm giving it a name, but that really never shows up. That's not important. What's important is I say to use this image. Now, there are 2 steps that we have to think about here. There is a Docker image, or you can give it a Docker file and do the build here. And then there is what happens inside your container. So these settings get applied, these extensions get installed, and the Visual Studio Code server-side extensions get installed. So your container is based on that image, and then has the other things layered into it. Now, good. I spent exactly enough time talking to get this ready. What you see now is Visual Studio Code Browser Edition. It is connected to the container. It has all of my code in it in a workspace, and it's got some of my extensions because in my Dev Studio or devcontainer.json, I said, hey, always install the Java pack and always install Calva. So it did, and now I've got Calva going, so I can start up a REPL in here. I'm going to start my just ordinary Clojure CLI dev REPL, and away it goes. This is running remotely. The browser obviously is here, but the container is remote. And in that container, I can even get a bash shell. So if I get my key sequence right, let's see. No, I don't want the Calva jack in. Yeah. Let's just try it this way. Oh, it's being really stubborn. There we go. So here, I've got bash. It knows that it's a container based on Ubuntu. It knows it's running on Azure infrastructure. You'll notice I'm root. Well, if you're in a container that gets thrown away, it doesn't really matter if you're root. So it's kind of just easy to do things as root. I'm in the workspace, so if I do my directory listing, you'll see the same stuff here as you see up here. I can edit all of my files. I can make branches. I can push code to my repo. And as you saw, I can run processes. Now, there's a couple of interesting bits that you have to think about when you're doing this. One is this container is running as me. It has checked out code from the repo that I chose, and it's installed the extensions from the repo that I chose. That doesn't have to be my repo. Shortly before this meetup started, I saw a post from Lynn Langett about her repo here, Learning Cloud. I don't even know what it does, but she's enabled it for code spaces. And so I can create a code space on her repo. Now, this is cloning all of her code to a new container, which I will be able to access and edit. I don't have any permissions to push code to her repo. So I can clone and I can start it. I could add a new repo of mine as a remote and then push to the remote. So I'm making a fork, which I could then use to create a pull request. So the workflow gets a little bit tricky. The other part is you have the possibility to personalize your containers by creating a repository called .files. Whatever you have in .files will get cloned along with your code space, and then every file in there named with a dot gets linked into home for your user. So if I go here, I should see .files, and indeed I do. These are my .files mixed with Lynn's code. So this is one of the places where we have to think hard about what the security and permission model is really going to be. Because the devcontainer.json and the Docker image are deciding what to run. My .files may have my information in them. So do I let Lynn's code run something that slurps up all my .files and ships them off over email? For this reason, GitHub right now requires that your .files repo must be public, and therefore you're strongly encouraged not to put secrets in the public .files repo, which makes sense. But notice all of this stuff that Lynn has here in her Learning Cloud repo. I shuddered to think what it would take for me to hook up GCP, Azure, AWS, Alibaba, all of that in my local environment. So getting back to the repo I made here and my code space, you can see I've just got some ordinary Clojure deps. But I mentioned that the image was interesting. So I also created a repo which builds a dev container suitable image with my Clojure stuff pre-installed. And this is just taken from the Clojure image from the Docker Hub. I wanted to make sure that I could get the version that I wanted, a very specific version. And I can customize this further if I need to. But the point is, there's a couple of steps. I build the Docker image. I refer to the Docker image here. And then the container starts based on that image, plus the modifications from devcontainer.json, plus my repo, plus my .files. And there you go. I see some questions over here. Some of them I can answer, some I can't. One more thing that I did want to mention, I can actually start Visual Studio Code running locally, so outside of the browser, and use its remote containers remote code spaces extension to go look at what code spaces I have and connect to a code space. When I do that, I'm freed from the browser tab, which is good because Control W is in my fingertips, and I keep closing browser tabs when I don't mean to. But there is a catch at the moment. Your code space only stays active while you're using it. It seems to be about 10 minutes after you stop using it, or 10 minutes of idle time, and it will shut down. The container, so the code space goes idle, but the container is not destroyed. In other words, anything I've edited or any uncommitted changes, any local edits, those are all preserved as long as I keep my code space around. But I have to reactivate it, which takes 2 or 3 minutes. When running locally with VS Code, it can't seem to tell GitHub to keep the code space active. So I've actually been in the middle of typing something in when the code space shuts down. So while it's in beta, I think I need to stick with the editor, or the browser-based editor. So getting to some of the questions, will this support remote runners like GitLab does? I don't actually know what that question means, so I'll have to ask you. Oh, I guess the next one does elaborate. I want to build something using Xcode on my home Mac, but I want to do it remotely from an underpowered non-Mac computer. Yeah, I don't think this is what you're looking for, Daniel, because this is it's a container running on an Ubuntu server, so I don't think you're going to be able to run anything Mac related inside of it. Really, this has to be something that you can completely run in the container. J.R. Smith, I've been using CodeServer locally on my Chromebook. Is CodeServer the thing from the coder.com folks? If so, I've tried that out as well. It's also pretty sweet. This is effectively the same feature integrated with GitHub and kind of one click away in the GUI. Daniel asks, can Cider running on my computer jack into nREPL running in code spaces? No, the ports are not opened up for general use at this time. There is talk of being able to tunnel through, in which case you would, but yeah, at the moment you cannot do that. If it does, that makes me nervous. Open port to a container with root. Yeah, agreed. Technically, Cider could find the code space container. I don't know if it even gets assigned a public IP or if all of the traffic is routing through some kind of a single point of front-end access and control. I haven't actually traced any of the packets to see how this is getting to my container. So yeah, a lot of the networking stuff, it's supposed to be magic. You're just supposed to use the browser-based code and not really know how the rest of it works. One thing I do find interesting, though, is when you set up the code space, you're building it from one repository, and that gets checked out in your workspace. But notice I'm in a subdirectory of the workspace, so I can come here and clone other repos. Well, once I put my key in, I don't have my keys in dot files because they're public. But once I put my key into this container, I could clone other repos side by side with this. So I could actually run my whole network of services in one container, even though it was spawned from a single repo, and that's what set up the dev container.json. Ivar says, if VS Code has a doohickey that does it, couldn't that protocol be reverse engineered? Absolutely. In fact, with as much of VS Code as is open source, it wouldn't surprise me if the extension was already open source. So we could take a look at that and see how it's being done. Anyway, I think this is a great tool for helping beginners get started with all kinds of things. So imagine a try Biff button that launches a code space for you, checks everything out, gets you ready to run. And then if you want to keep your project, you push it to a new repo of your own, and you're off and going. Another question came in, Proctor. Multiple things could be set up in a Docker base image that you use. Yes, absolutely. Like always, you're going to have this tension between wanting more stuff in your Docker image to make it faster, but it's also more specific, and so it's less generally reusable. I kind of had this thought that my Clojure dev container is good for any Clojure project I do, and then this Dawn repo is a nice starter for a pedestal vase datomic web service built in Clojure. So kind of layers of specialization and instantiation. Anyway, that's all I have. So John, back to you.
Sure. Yeah. Thanks a lot. And that looks really interesting as well. So I can't wait to take a look at that as well. And this is my first exposure to your Dawn repo. So I may want to follow up with you after the meetup, see if we could learn some more about that repo at a future meetup.
Yeah, sure. I mean, it didn't exist until a week and a half ago. So it's everybody's first exposure. Like,
oh, right.
Literally, you are all the first to know about it.
Good deal. So, yeah, good deal. Well, yeah. Hopefully, maybe we'll be seeing more of that a bit later. All right. Well, anyway, thanks everyone for coming, and so once again, I want to thank Daniel Craig for helping coordinate the speaker for tonight. And as always, if you have any suggestions for a future topic or a speaker that you want to see speak at this meetup, then please introduce me, and then we'll get them in the queue. Right now, we don't have anyone immediately queued up for September, so that'll be coming out soon. And as soon as we get someone, we'll get the abstract and bio up on meetup.com. So anyway, find me in Slack, and then and we'll get you going. So thanks again, everyone, and we'll see you next month. Bye.